Good morning to everyone. We're going to start today's session. So today we're going to start with new topic, which is SLT. So SLT stands for SAP Landscape Transformation. SLT is used to transfer data. SLT is used to transfer data in real time. It could be an SAP system or a non-SAP system. Let's say we have SAP system which is ECC. A non-SAP MS SQL. So SLT is installed on a separate host. It's installed on a host is nothing but a computer. So it is installed on a separate host. SLT can be installed on a separate host, or SLT can be inside ECC system. It can be installed as a separate host, or it can be inside the ECC system. The communication between ECC and SLT is an RFC connection, a remote function call. So remote function call is the communication between ECC and SLT. The communication between a non-SAP and SLT system is a DB connection. It's a DB. So this is a DB connection and this is an RFC. So SLT to HANA is again a DB connection. SLT to HANA is again a DB connection. SLT has two versions. SAP Landscape Transformation has two versions. One is 1.0, and the second one is 2.0. How do we know whether a system has 1.0 version or a 2.0 version? It is based on DMIS. There is DMIS. So based on DMIS, if it is 2010, the DMIS is an add-on. If DMIS is 2010, it is 1.0. If DMIS is if DMIS is 2011, it's 2.0. So how do we know what is the DMIS and where do we check in this? Where do we check in this ECC system? Or where does, if SLT lies in the ECC system, we have to check DMIS in the ECC. If SLT is installed outside the ECC system, we have a separate logon to SLT system. ECC and SLT both are ABAP based systems. Both are ABAP based system. ECC is an ABAP based system, and SLT is also an ABAP based system. In order to check, click on SAP GUI. In our landscape, SLT is on the ECC system. It's not on a separate host, but usually when working on the real-time projects and working on the real-world projects, SLT is installed as a separate host. But in here, what we have done is, the way that we configured over here is, because we are using for educational purpose. So the way we have configured is, because we do not want to have SLT as a separate computer, so we directly configure inside the ECC system. Because in the real world, there are thousands and thousands of jobs that are running in the background for SLT. You have 2 minutes tables to replicate. But when we do practice, probably we may not replicate so many tables. So that is the reason we directly configured on the ECC system. So in order to check DMIS, I log on to the ECC and check this DMIS version. So let me log on. It is just cost effective. So when you install SLT on the ECC, it's basically cost effective because we are only having one computer rather than having two computers. So once you log on to the ECC, click on Systems. Let us click on Status. Click on Component. So if you scroll down, you scroll to the bottom, or you can just click on Find. Click Find. Find for DMIS. So DMIS is 2011 and service pack is 08. So it is 2.0 and service pack is 8. If SLT is on a separate host, now we will have a separate logon to log into SLT system. Because it's on the ECC, I logged on to the ECC. So whatever the activities I'm going to do for SLT, I'm going to directly do in the ECC system. But usually, it has a separate host, separate instance number, a different application server. Everything is separate. Now, why in real world we do it as a separate is because we don't want to have burden on the ECC system. We keep them as a separate because we do not want to have burden on the source system, because even the source system has majority of the work creating orders, writing and reads of data. That's why we keep it in order to load balance between the systems. We keep them as a separate systems. So the communication between ECC and SLT is an RFC because both of them are ABAP based systems, remote function call, and the communication between MS SQL and SLT is a DB connection, database connection, and SLT to HANA is a DB connection. Now, when working on the SLT projects, there are basically two roles. We have two roles for SLT projects. The first role is the SLT admin, or these activities can also be done by HANA administrator. And we are part of HANA application consultant team. So the knowledge about admin is useful for application consultant. The reason is, whenever we try to do troubleshooting from end-to-end systems, in order to pinpoint what is the exact issue, or in order to do root cause analysis, so SLT admin related topics will be very useful in real world, because it involves in several places to check whether the issue is in the SLT system, whether it is on the HANA system, whether it is on the configuration, whether it is the communication method, whether it is on the source system. In order to troubleshoot end to end, we also need to have the knowledge about what an administrator does is important to us. So first of all, when we have ECC, SLT, HANA. Now we just discussed that ECC to SLT is an RFC connection. The RFC connection is created in the T code SM59. So SM59 is a transaction code where the admin creates the RFC connection. So step number one is to create an RFC connection. Create an RFC connection. So where does the admin create RFC connection? In the T code SM59. So then ECC and SLT will start communicating to each other. Step number two, there is a T code called LTRC. LTRC stands for LT Replication Server Cockpit. LT Replication Server Cockpit. So all the SLT related activities. So this is the main transaction code where we do all the SLT related activities. LTRC, LT Replication Server Cockpit. So once we are inside this transaction code, HANA admin or SLT admin can create a connection. This connection we call it as configuration. The connection here is known as config. Configuration. So we need to create a configuration. We're just creating a connection, but in other words, we call it as a configuration. So this configuration we create in LTRC transaction code. So when creating a configuration, we mention what is the source system we want to connect. Whether we want to connect to MS SQL, whether we want to connect to a database, or we want to connect to an SAP system. They mention this in the configuration. So which type of system do you want to connect? To an SAP system or to a non-SAP system? So we need to mention what is the source system. What is our source system when creating a configuration? So what is the source system that we want to connect? That is step number 1. That is inside the configuration. We need to mention this. What is the source system? And what is the target system you want to connect? The target system is obviously HANA. So source system is ECC and target is we would like to connect to HANA. So when you're transferring data from ECC to HANA, there are jobs that are running in the background to transfer data. So tables are on the ECC system. Now these tables we want to transfer to HANA. So in order to transfer this data to HANA, we require jobs. And these jobs are nothing but these are known as background jobs. So we need to mention how many jobs we require to transfer data from ECC to HANA. So how do we decide how many jobs we require? So SLT admin has to decide how many jobs they have to require to transfer data from ECC to HANA system. So this is based on our requirement. For example, if my requirement, let's say the application team has taken the requirement from business, the application team, when they come up with the technical specification, in the technical spec, we'll have what are my source tables. Let's say I have, for example, let's say we have 4 tables to replicate in real time. For 4 tables, we require one background job. One background job consumes 0.5 CPU. So in order to replicate 4 tables in real time, we require one background job, and one background job consumes 0.5 CPU. Let's say 8 tables means 2 background jobs. 2 background jobs require 1 CPU. Nothing but 1 core. So when working on the SLT systems, you have small scale SLT, a medium SLT, and large SLT. So in a small SLT, when the systems are known as small SLT systems, small, medium, and large. So the configuration of small scale SLT it would be 4-core CPU and 8 GB of RAM. So we require 4 cores and 8 GB of memory. When you have medium scale SLT, you have 8 cores, 16 GB of memory. When you have large SLT systems, you require 16 cores, 32 to 64 GB of RAM. So this is the configuration of SLT system. So 4 cores, 8 GB of RAM, 8 cores, 16 GB, 16 cores, 32 to 64. For every 4 tables, we require 1 background job, and for every 1 background job, we require 0.5 CPU. So based on the tables that we are replicating, so how many tables we replicate? Based on that, the admin does a sizing of the system. So the admin basically sends us a template. They will send us a template, and that template will consist of, they're going to ask us few questions over here. They are going to ask us, okay, fill in all the tables over here. Fill the tables, and then what is the volume of data that you expect on a daily basis? So all the tables, volume of data, frequency of data load. So how frequently you want to load these tables to HANA system. Whether you have any batch jobs. So basically this is real time and this is batch. So basically tables, for example, KNA1 table, volume of data. So what's the volume of data that you expect? Let's say 100K. Whether this table you want to do it in real time? No. You want to do it in batch? Yes. VBAK. Real time? Yes. Batch? No. So like this, we're going to fill up this template and pass on this template to admin people. So based on this, they basically do the sizing of the system. Okay. So this is all we do it in the configuration. So when creating a configuration, we need to mention what is the source system we want to connect, whether it is an SAP system or a non-SAP system. What is the target system we want to connect? How many jobs we require? Again, in these jobs, we have different kinds of jobs. One is known as initial jobs, and the other one is known as replication jobs. So what is the difference between an initial job and replication job? So initial jobs are those jobs which are mainly involved to transfer data. So initially we are going to transfer the entire data. Initial jobs are those jobs which we transfer the initial data from ECC to HANA. For example, in KNA1 table, let's say I have 1,000,000 records, for example. So the first, I need to transfer the entire 1,000,000 records to HANA system first. So that is taken care by the initial job. And later, every day there are new records that are created in the customer master table. For example, today I created few hundred customers. There are 100 new customers, and these new customers are updated in KNA1 table. So the replication job will take care of those 100 records. So initial jobs is a job that transfers the entire data. For the first time, it will transfer the entire data. That is also known as full load. Full load is taken care by initial jobs. Replication job is nothing but newly created records. So every day there are newly created records. Today I'm going to create new records. Tomorrow we are going to create another new records or change records. So the entire 1,000,000 records are transferred via initial job. And the replication job transfers every day newly created records or changed records. So we talked about one job for every 4 tables. So how many jobs we require for initial and how many jobs we require for replication jobs? For example, I have 4 replication jobs. %50 of the replication jobs are initial jobs. So if you give in replication job as 4 jobs, then you have to give initial jobs as 2 jobs. Because this is a one-time activity. Initial jobs is a one-time activity, and replication job is a daily activity. So for initial we use 2 jobs. 50% of the replication job is the initial job. So when we're creating a configuration, we give what is the source system, what is the target system. For every 4 tables, one background job. Each background job consumes 0.5 CPU. Again, in these jobs, we configure initial jobs and replication jobs. Initial job is a job that transfers the entire content. It transfers the entire content of the source data to HANA, and replication job newly created records or changed records to HANA. So once we configure in step number 2, all this we do it in the configuration. And then once we finish the configuration, so in step number 4, once we complete the configuration, so where are we doing this configuration? In the SLT system. In the SLT system, in the T code called LTRC. In here we are doing the configuration. So once we complete the configuration in SLT system, for example, we have given this configuration name as ECC SLT, for example. For example, we have given this configuration name as, in the SLT system, we have given as ECC SLT, for example. With the same name, with the same name of the configuration, Automatically, system creates a schema in HANA. System creates a schema. Automatically, system creates a schema in HANA system with the same name as the configuration name. Once the schema is created, and this is for SLT, all the SLT tables will be replicated into the schema. So if the configuration is successful, whatever the configuration that we created is successful, a schema is created, and automatically system will start replicating few set of tables, DD02L, DD02T, DD08L. So all these three tables, system will start replicating to HANA into the schema. So once these tables are replicated, these tables will have the status. They'll always have the status. So for every table there is a status maintained. These tables will have the status replication in process. So replication in process means these tables are always updated in real time. All these tables are always updated in real time. Okay, once again, let us see until the configuration part. So SLT stands for SAP Landscape Transformation. SLT basically has two versions. One is 1.0 and 2.0. We can know the version of SLT by looking at the DMIS in the system. So the DMIS is 2011 is 2.0, 2010 1.0. ECC to SLT is an RFC connection. SLT to HANA is a TB connection. Communication between a non-SAP system is a DB connection. SLT can be configured as a separate host, or SLT can be inside the ECC system. SLT admin or HANA admin does the following steps. Step number 1, both the systems have to communicate to each other. He creates an RFC connection in the T code SM59. There is a central transaction code, LTRC, LT Replication Server Cockpit. So using this transaction code, I can create a configuration. A configuration is nothing but the connection between ECC and SLT to HANA. For every configuration that is created by system, there is a new mass transfer ID generated. New mass transfer ID. Mass transfer ID is the ID that identifies each configuration uniquely. For example, let us take one example. Let's say I have ECC, I have CRM, I have SCM. I have three SAP systems. One is an ECC system, and second one is CRM system, and third one is an SCM system. So all these are my source systems. So ECC to SLT is one configuration. So it will have, let's say it is starting from 01. Configuration starts from 01, mass transfer ID. So the name of this configuration is 01, MTID is 01, CRM to ECC, MTID is 02, this is 03. So for every source system, for every connection, the connection is identified by the mass transfer ID. This number is uniquely generated by the system. So once the configuration is successfully created, a schema is automatically created in HANA. In this schema, tables like DD02L, 2T and 8L. Tables like DD02L, 2T and 8L. These tables are automatically replicated to HANA system. So once these tables are replicated, these tables have the status replicate in process. So that is the part of the SLT admin or HANA admin. So SLT has two UIs. SLT has two UI. In order to work on SLT, you can work on HANA. You can work on HANA using HANA Studio data provisioning, or you can work in the T code LTRC. So let me show you both these UIs. I'll just try to show both these UIs. So let us log on to SAP system. That's on the ECC. We have SLT on the ECC system. I'll enter the T code LTRC, LT Replication Server Cockpit. Click enter. SAP LT Replication Server Cockpit. So every configuration is identified by the mass transfer ID. And these are nothing but the configuration names. So we'll see how a configuration is created. So this is a configuration name. Whatever the configuration that you see here with the same name, a schema is created in HANA. Click Start. Let's open HANA Studio. Let us log into So once we log into HANA system, Here we see the configuration name. With the same configuration name, expand the catalog. Tata is one configuration. Let's go to configuration called Tata. So this is the schema name. Expand Tata. Expand tables. So here is where you have all the SLT tables. So these tables that we see here, we have a special UI for SLT inside the HANA modeler. So let us click on SAP HANA modeler. So once we click on the modeler, in order to see quick view, click on show view, click on quick view. So once we click on quick view, so here we see data provisioning. Click on the data provisioning. Select the system that you want to perform this operation. Let's select this. Click finish. So once we click finish, if you open this SAP data provisioning editor, in the SAP data provisioning editor, please see what is my source system, what is the target schema. So target schema, what is the target schema is nothing but the configuration name. So you see, once the replication is successful, DD02L, 2T, 8L, action is replicate in process. So once the configuration is successful, you'll have the schema. You have the schema created, and DD02L, 2T, 8L tables are replicated in process. So for the application consultant, TC in the HANA Studio, we have these options: load, replicate, stop replicate, suspend, and resume. So these options are important for application consultant. These same options, what are the options that we see here? These options are also available in, when you click on Tata, when we click on data provisioning, these options are also available in LTRC T code, load, replicate, stop load, suspend, and resume. So all these options are available in the SLT system that's on the ABAP based system, and HANA Studio is based on Eclipse. HANA Studio is based on the Eclipse environment. Even in the Eclipse environment, these options are available. So the application consultant team can work on both these areas. They can work on HANA Studio data provisioning or in the LTRC. So the options that are available: load, stop load / replicate, suspend, resume. So these are the 5 options that are available for the application team to perform the activities. So first let us start with what is load. So these are the 5 options. So what is load? Load is nothing but full load. Load is especially used for non-frequently changing data scenarios. Non-frequently changing. When the data that is not frequently changing on a daily basis. For example, let us take this table T005T. T005T is a table that consists of country text. It basically consists country text related data. So we know once we load, for example, I'm doing business in, let's say, 110 countries. For example, I'm doing business in these countries, and this is the data I have. My customers are associated, all my customers that are doing business with me are associated with these 120 countries. So every day, on a daily basis, there is no new country created because there is only 120 countries I'm doing business. So every day this data is not going to change. So once I load all the country data to HANA system, all the countries, all the 110 countries are loaded into HANA. If there is any change in future, for example, I started doing business in other 3 countries. I can get those 3 countries. Again, I can do load. So load is only one-time activity. So load is basically only one-time activity. Whatever the data that we have, we load all the data to HANA. Complete. The job is complete. Job is finished. So the status of the job is completed. So once the job is completed, whatever the data that we have here, we also have the same data in HANA. If in future any additional records are created, let's say there are 3 more countries I added to the source system. So in that case, what I'm going to do is, I'm going to do load again. In order to load these 3 records, I'm going to perform the load again. So this time what system does is, it will delete the entire table. So by default, what system is going to do here is, it's going to delete the entire table. It's going to delete the entire table, reload the table again, recreate the table again, and reload the data again. So every time, whenever there are any changes on the source system, the default behavior of load is, it deletes the previous table, whatever is already loaded, it deletes the previous table, recreates a new table, and reloads the entire data of the source system to HANA system. So that is what the load can do. So load is mainly used for non-frequently changing data scenarios. Whenever the data is not changing on a daily basis, but still it change. Whenever there is a change, only during that time I reload the table again. Once I reload the table again, the existing table will be deleted by system, a new table is created and loads all the data. That's what the option load can do. So load is mainly used for non-frequently changing data scenarios, especially for master data. So we know the definition of master data is the data that is not going to change frequently. So a load is used for most of the time. A load is basically used for master data. Now if you have frequently changing data scenarios, if the data is changing frequently, every day new sales orders are created. Every day, for every hour or for every minute, data is changing frequently. Then we go for replicate. So replicate is an option. So today I'm only discussing the theoretical part. I'm only focusing on the theory part. Tomorrow we start the practical for this. So replicate is mainly used for frequently changing data scenarios. Every minute, for every second, data is being changed. Then we go for replicate. Frequently changing data scenarios, especially transaction data. We use replicate for frequently changing data scenarios. Stop. Stop is to stop these jobs. Means there is no communication between we're going to stop the communication between the table on the source and the table in the target. So whatever insert update I'm doing into this table, this is not updated to HANA. This data is not updated to HANA system. Suspend. Suspend is temporary halt. So temporary halt means you're going to temporary halt data transfer between ECC and HANA. The data is temporarily halted on the ECC system. So for example, if you want to restart HANA system, because HANA system is down, it is not in a position to receive any more data. So during that time, we do suspend. So we suspend these jobs unless and until HANA system restarts and the database is up, and then we release these jobs. So temporary halt is suspend. Stop is permanent halt. Resume. So after you do suspend, after we suspend, we resume. So load is one-time activity. Whenever you load data, it's a one-time activity. If any changes in the source data, we have to load again. Replicate. For frequently changing data scenarios. Stop. Permanent stop of communication between source and target. Suspend. Temporary halt of data on the source system. Resume. Again, data from source is updated to HANA. Stop is permanent. Permanently we are stopping. So when you stop, we cannot resume. Only when you suspend, we can resume. The stop cannot be resumed. To stop is to start. To stop, when you stop, you need to start. But when you suspend, we can resume. So tomorrow we'll see more details into each one of them. So just I'm trying to give you a very high level overview today. Tomorrow we'll see more details into each one of these activities. So any questions until here, please ask me. So here we have one question here. Can we use BODS for initial loads and then use SLT for replication? We can use, but this is not a best practice. The reason is SLT also need to understand what data is sent. For example, I have 10 records. SLT should mark somewhere that these 10 records are already sent. And from now onwards, I'm only going to send newly created records or changed records. Because already I sent 10 records now. From next time, whatever the data I'm going to send is only newly created or changed records. So for SLT to understand this, it should note down somewhere, okay, these records are sent and these records are not sent. So that's why load and replicate should only be done by SLT system. If you do with BODS and SLT, both of them cannot reconcile data. What data is sent by BODS, SLT cannot understand. What data SLT sent, BODS cannot understand. That's why it is not a best practice to use for the same table to load the same table and to replicate the same table in the same schema. Next job. So next question. Can we resume the stopped job? We cannot resume stop job. Resume is only temporary halt, but stop is permanently, it is stopping the mechanism of replicating the data. So when you stop, we need to start again. But when you suspend, we can resume. So next question. After stopping, if you want to start again, what do we do? Is there an option to start? So once you stop, again to start, you have two options. One is to load, and the other one is to replicate. One is to load data, and the other one is to replicate. So using both these options, we can start. What is the major difference? What is the major difference in DMIS 1.0 and 2.0? Whether SLT having in the ECC system? There is no major difference at all. The difference here is when initially SLT was released, they have this version 1.0. And later they released the second version of SLT, which is 2.0. But whatever the features that 1.0 has, whatever the features that 2.0 has, even 1.0 also have the same features. But the service pack is different. For example, if I have in 2.0, in here I have 2.0 SP8. Whatever the features that I have in SP8, in 1.0 I'll have in SP12 because that is released first. The service packs are different. So in here, if I have an SP8, the same features are available in SP12. So the versions of the service packs are different. Otherwise, when a new service pack 9 is released, for example, or 10 is released, it will have the corresponding service pack released in 1.0. Functionality wise same, but only the versioning is different. Versions of the service packs are different. So is there any RFC monitor transaction available? So SM59, in the SM59 we can check, when you double click on the connection test, there is an option to test the connection, whether the connection is working or not. So if the connection is basically, if some data is missing or the jobs are being failed by SLT system, we can check in this T code, SM59.